So reviewing for the Chapter 1 test over linear equations and linear functions. Again, just like before, this should be used where you do the work and then use the video to check your work, not using the video to just write down what I write down, right? So you're practicing and then checking your work using the video, making corrections as needed. So stating whether it's a domain, or stating the domain and range, then determining whether it is a function or not, right? So your domain, list of all x values, -2, 3, 4, and 10. As I'm doing that, I'm looking for repeats in the domain. That's going to help me out with checking if it is a function. -1, 0, 2, 4, and 6. Those are my range, right? Inputs and outputs. Right? So looking at functionality, is it a function? 4 produces 3 different things, right? 4 went in the machine, 0 came out. 4 went in again, 2 came out. 4 went in again, 4 came out, right? So the machine is not functioning properly. It is not a function, right? So the answer there is no. No, it is not a function, right? You can have multiple arrows going to a value in the range, but you cannot have multiple arrows coming off of the domain or repeated domains with different outputs. So subbing into function notation, right? For number 2, f of 6, that means I want to look at the f of x function, right? I'm going to be right here because it says function f and 3 times x. Well, they tell me right here that x is 6, right? So I'm going to use order of operations. 3 times 6 is 18. 18 minus 6 is 12. For number 3, g of 2, right? So now I'm looking at the g function, right? Because it says g of 2. So I'm going to switch to that other function, and I know that my x value is now 2, right? So 9 minus 2 squared. Well, 2 squared is 4, right? 9 minus 4 then would be 5, right? So that's just substituting in and solving. For number 4, we're asked to graph and then tell the intercepts, right? So we have a y equals equation. So y equals mx plus b, b being my y-intercept. So my y-intercept is at -6. So 0, -6. And then I can use my slope then of +3 to find an additional point. Up 3 over 1. Up 3 over 1. Right? So my line's going to come through like that. Right? And it has a x-intercept right here at 2, 0. Here we have standard form. This is where we could do the cover-up method, right? To find the x-intercept, we get rid of y, right? So I could put my hand over y here. And I put my hand over y. I cover up y, right? So negative x minus 2, right? So negative x negative x equals 2, right? I divide away the -1. I get x equals -2. So my x-intercept is -2. And then I will find the y-intercept. And to do that, I cover up x, right? And I am just left with y equals 2. Right, so right there. And then I connect them. If you wanted to full algebra this to find the x-intercept, We already know here that y is 2. 0 minus x equals 2. And then to find the y-intercept, we know that y minus 0 equals 2. And then you could solve those out using algebra that way also. Finding the slope using 2 points, change in y over change in x. Label out your points. Call this P1. This one's P2. Y2 minus Y1 divided by P2, or X2 minus X1 . Right, so -1 minus 8 is -9. -7 minus a -4 is -3. And -9 divided by -3 is 3. Looking at number 7, right? Subtract your y's divided by subtract your x's. And we do the same thing. We establish which is 0.1, which one is 0.2. So I'm just going to go in order. P1, P2. Y2 minus Y1. X2 minus X1. So I get 0 over 10. So 0. Right? So it's a flat line. For number 8, Y2 minus Y1 divided by X1, or X2 minus X1, right? If you ever get confused, right, make sure that your points are stacked on top of each other, right? My 0 and 1, or 0 and -6 are stacked. My 5 and -9 are stacked. And then we do our math, right? -6 minus a -9 is +3. And 0 minus 5 is -5. So -3/5. Here, determining rate of change, right? We have points on the line. So I am going to, right here, right, count from here. They're right on the grid. Up 2, right 1. So 2 over 1, right? 2 over 1. 2 divided by 1 is 2. For number 10, I'm going to use this point here and this point here because they're right on the grid lines. Down 1, right 2, -1/2. Using the graph to get slope-intercept form. So that's going to be y equals mx plus b. Right, that's the generic form. Y equals slope times x plus y-intercept. This gets a little tricky because my y-intercept is not a perfect, it's not perfectly on a grid line. But what I can do is find slope using that point and that point. Right, so I have a slope of down 3. And then right 1, 2, 3, 4. Right, so I have a slope of -3/4 plus my y-intercept that I don't know yet. Right, so I can use a point, and I'm going to use this point right here of -1 comma -2. So y equals mx plus b, -2 times -3/4 x, which is -1 plus b. Right, I'm using the data from that point. So I get -2 equals +3/4 plus b. Subtract away the 3/4. It would get negative 1 point, negative 2 3/4. Right? Negative 2.75. And I can see that here. My negative 1, negative 2, almost negative 3, but not quite. Right? So that one's a little trickier because your y-intercept is not on the grid line. So some solving here. We can use elimination on number 12. Right? If I multiply all of this by 2, right, my first equation is still 2x plus 3y equals negative 9. My second equation then becomes 2x plus 2y equals negative 4. And then when I subtract these, right, 2x minus 2x is 0x, 3y minus 2y is y, and then negative 9 minus a negative 4 is 5. Right, so there's half of my ordered pair. And then I'm going to sub that in, x plus y, which is 5, equals negative 2. So when I subtract that 5 away, I get negative 7. For number 13, I'm going to use substitution. X minus y equals 9 here in the second equation. Up top, they tell me x equals negative 2y. So I'm going to sub that in to the second equation. X minus y equals negative 9. But instead of writing x, I'm going to write x's other name, which is negative 2y. So that gives me negative 3y equals 9. So when I divide away that negative 3, I get y equals negative 3. Right, so there's half my solution, and I am going to use this this first equation here to get my other coordinate. So x equals negative 2 times y, which we just learned was negative 3. So x is equal to 6. All right, so working to run elimination on a 3-variable, 3-equation system. Right, we're going to have 2 sets of equations that we run elimination on. Right, so I'm just going to go with first 2 and the second and third. And I have to decide if I'm going to eliminate x, y, or z. And x or z would be a good first start because I see commonalities in them. So let's just work to eliminate z. Right, so copying down those first 2 equations. Right, x plus y minus 2z equals 5. And then negative x plus 2y plus z equals 2. And if I add those 2 equations, right, x plus a negative x cancels. That gives me 3y plus z that gives me 3y, and then negative 2z plus a z minus z equals 7. And then for my second 2, negative x plus 2y plus z equals 2. Cross my z's there because all my z's and 2's look kind of the same. And then 2x plus 3y minus z equals 9. Right, if I multiply this whole equation by 2, that gives me negative 2x plus 2z equals 4. Right, and then my x's will cancel if I add. Right, 2x minus plus a negative 2x is 0x. 3y plus 4y is 7y. Negative z plus 2z is plus z. and then that would equal 13. So I have these two equations now to work off of. I have not made any progress towards finding, well, I've made progress. I have not found an x, a y, or a z yet. Okay, but now I have these two equations, and if I add them, right, I get 3y plus 10, or 7y equals 10y, z, negative z plus a z equals 0z, so 10y would equal 20, so y would equal 2, right? And when finding my ordered triple, x, y, z, I now have my y is 2, right, from right here. So now I am going to use one of my two equations that I worked off of here to find one of my other variables. Let's get a new color going here. So let's just go right here, 3y, which I learned here was 2, okay, minus z equals 7, right? So 6 minus z equals 7. If I subtract 6 from both sides, I get negative z equals 1. So z then would be negative 1. Right, so that gives me my next piece to the puzzle here. Z equals negative 1. Kind of running out of room, but we're going to be okay. X plus y plus 2z equals 5. I'm going to use x. I don't know x, right? But I do know y and z. X plus y, which I know is 2, minus 2z, which I know is negative 1, equals 5. So x plus 2 plus 2 equals 5. So x plus 4 equals 5. If I subtract that 4 away, I get x equals 1. So those are a lot of work. Looking at some SAT style questions. Neighborhood consists of a 2-hectare park. Hectare is a measure of area, and a 35-hectare residential area. The total number of trees in the neighborhood is 3,934. The equation 2x plus 35y equals 3,934. Which of the following best represents x in the context of the problem? Well, we know that this is total trees, right? We know this is total trees. We know that this is total trees. We know that 2 has to do with the park, and the 35 has to do with the residence. Right? So what is x? X is attached to the park, right? To this 2-hectare park. So we know that this x has to have something to do with the park. The average number of trees per hectare in the park, the average number of trees per hectare in the residential area has nothing to do with the residential area. Total number of trees in the park, total number of trees in the residential area. So we've eliminated B and D because they do not reference the park at all. Total number of trees in the park, looking at C, well, that doesn't make sense because there's no reason to multiply it by 2, right? So it would have to be A, the average number of trees per hectare in the park. Here we're looking to use the graph number of cornflowers and wallflowers at a garden store. The points plotted in the coordinate plane represent the possible numbers of wallflowers and cornflowers that someone buy at the garden store in order to spend exactly $24. Right? The price of each wallflower is the same, and the price of each cornflower is the same. What is the price in dollars of one cornflower? So here is what we know. We know that when we add everything together, it has to equal $24. Right? I also know that, let's just call cornflowers, wallflowers and cornflowers. This is on the x-axis, cornflowers is on the x-axis, wallflowers is on the y-axis. So x plus y. Okay, I know these have to have a price. So I have to have a price for cornflowers and I have to have a price for wallflowers. Okay, looking at the graph, if I eliminate wallflowers altogether, right, they want me to find the price of cornflowers. If I eliminate this whole part, if I set this equal to 0, it doesn't matter what the price is, right? So if I then do that, I know I have to buy 16 cornflowers. Okay, and I'm going to just assign this price here. I'm going to call it P for price. Right, so P times 16 equals 24 because it tells me that this combination in the graph is for cornflowers and wallflowers totaling $24. Right, so we're used to seeing it like this, and I know I have to divide away that 16. Right, so I would just then use my calculator for this. I would do 24 divided by 16 and get 150, right? 1.5 for my price. So the price of each cornflower is $1.50. So two companies, internet service providers, charge monthly fee and an installation fee. Company A, Company B. Company A gives us a table, Company B gives us an equation. So part A asks us, which company charges less per month? Well, we see right here that the slope of this line is 45. So company B charges $45 per month, right? That is their cost per month. Company A, we'd have to calculate, right? Goes up a month. How much did my bill go up? It costs $40. So company A charges $40 a month, while company B charges $45 a month. So company A charges less per month. After how many months of service are the costs the same? Right. So if you're in maybe a short-term rental or something where you know you're not going to need internet for a long time, you need to weigh those different startup costs and see which one is the better deal for you. So we need to write an equation then for company A. We know their slope, right? It's 40. We're going to use one piece of data here to find their startup cost. So Y equals, which is 180, $40 per month times 2 months plus their startup cost, which is our y-intercept. So I get 180 equals 80 plus B. So then I know then that my B value is 100. So how long is it going to take to make up that difference of paying $100 startup cost for company B? And to do that, we're going to write the two equations equal to each other. 45x plus 50. That's company A. is equal to company B, which would be 40x plus 100 for their startup cost. If I move all the x's to the left, subtract 40x from both sides, I get 5x. If I push the startup costs to the right, 50, subtracting 50 from both sides, so x equals 10. So after 10 months, at exactly 10 months, the two companies cost the same amount of money over those 10 months. So that is it for our review. I know I skipped number 17. It wasn't a very good problem, so I'm going to take a look at that, changing out that problem. Test is tomorrow. Make sure you ask questions so that you are ready to go.